Hi, so this is Geometry Review 5. Review 4 was question 1 to 5. Yeah, question 1 to 4. I don't remember if I've done the fifth one. Yeah, I did the fifth one. So we'll move on to the question number 6. Yeah, right. So we have a triangle, and as you can see, it's a big right triangle ABC, and then two smaller right triangles, one on the left, one on the right. Now, there are two ways we can solve this question. Yeah. In the triangle given above, if BC is 20, then which of the following could be the measure of AB and AC given AQ is 8? So, the shorter way to solve this, there are actually two long ways and one shortcut, a trick way to solve this. So, I'll show you the test way of solving this. Okay. So, AB and AC, if you see, they are two, it's a base and a height of the triangle ABC. Okay. So, if AB is X, yeah, I'll use a different color. If AB is X, yeah, and AC is Y, then half X into Y is the area of the triangle ABC. And the same area is also half BC base into AQ height. Okay, so therefore this portion and this portion, they both are equal. So half X into Y is equal to half 20 into 8. Okay, so therefore X into Y is equal to 160. Now, is this if which of the following could be the measure of AB and AC? So if these two are AB and AC, then 3 into 5 should be 160. It is not. 3 into 5, 15. 15 into this is roughly 2 and roughly 2. So again, not. It's not adding up, multiplying to 160. 4 and 5, 20. 20 times 3, 60. No. 4 and 8, 32. 32 times 5, 160. So that's your answer. Got it? Now, if you were to solve this to actually get 4 root 5 and 8 root 5 as the answer, then there are two ways to solve this. Excuse me. So, one way is using Pythagoras theorem, and the other way is using similarity. So, we'll use similarity first. So, similarity of triangles. Triangles are said to be similar if the angles inside are identical. So, suppose if I say for the big triangle ABC, this is angle A and this is angle B. Okay, right? So the big triangle ABC has angles 90 degrees A and B, like that. Okay, under A is 90, under B is A, under C is B. Now, if you look at the left hand side triangle ABQ, then this angle at A, we don't know, but we know that the angle at B is A and angle at Q is 90 degrees. So we know that if a triangle has measurements 90 A and B, so we know that A and B is 90 degrees. So if 90 and A is given to you, then this has to be B. Can't be anything else, right? Because A and B is 90, correct? If A and B is 90, then these two together is also 90. So that way we come to know that this over here is B. And similarly, this over here is A on the right hand side. Triangle A C Q. Okay. So so obviously out here, I'll write it down in the order of BA 90. So BC AQ. Okay. Because under C we need a B, under A we need a A, and under Q we need a 90. So if this is just to show you that uh, all the three triangles, left hand side, right hand side, are the big one. They're all similar to each other. So how do we work the similarity part? We take the corresponding sides. Okay. So if we work left hand side and right hand side triangles, then the ratio of the corresponding sides. Okay. So opposite angle A out here is 8 in the left hand side triangle, and opposite angle B is, let's call it M, and that should be equal to the same thing on the right hand side triangle. Opposite angle A, yeah, we have 20 minus M, and opposite angle B, yeah, is 8. So here we got a first equation, 64 is equal to 20M minus M square. Okay, so once we get M, we can find out the values X and Y, which is AB and AC. So let's do that. So out here, this is a quadratic equation to be solved. M square minus 20M plus 64 is equal to 0. Now we know 16 fours are 64, right? If we take both as negative, then we get M minus 16, M minus 4. Yeah, that adds up to negative 20 for the minus 16 minus 4. And when you multiply minus 16 minus 4, you get plus 60. So therefore, we know M is 16 and M is 4. Okay. And once we know that M is, let's take this as 4, then this is 16. So now I know that X square is equal to 64 for the left hand side plus 16. Okay, which is equal to 80. Yeah, and 80 is 16 into 5. So we know X is 4 root 5. Similarly, Y square we know is 64 plus 16 square, 20 minus n. That is 256. 4, 260, 320. So y square is 320. Okay. So out here, we can break down y square as 16, yeah, into 580, 80 into 4, 320. So out here also we got y is equal to 4 root 5 and 2, and that is 8 root 5. And that's how we got these two values. Okay. So that is using similarity. Now let's use Pythagoras theorem. So using Pythagoras theorem, yeah. Suppose this is x and y, and this is m and 20 minus m. So I know that the big triangle x square plus y square is equal to 420 square. The whole thing BC is 20 square. BC is the hypotenuse for triangle ABC. We know on the left hand side, so big triangle, left hand side triangle, we know x square hypotenuse is 64 plus m square. And right hand side triangle, we know y square is equal to 64 plus 20 minus m the whole thing squared. So that way we know that when we add these two equations, we get x square plus y square is equal to 64 plus m square plus 64 plus 20 minus m square. Okay. Now x square and y square we know is 400. So therefore we know 400 is equal to 64, and 64 is 128 plus m square plus 400 plus m square minus 40m. So this is the expansion of this a minus b the whole square. So 400 and 400 cancel. So we got 0 is equal to 128 plus m square, 2m square. Sorry about my writing. 128 plus 2m square minus 40m. We divide 2 throughout. So 0 is equal to 64 plus m square minus 20m. Now this is the same thing as the equation that we got in the similarity. So therefore we get m is equal to 4 and m is equal to 16. Again we plug in m as 4 here and 16 here. Okay. So when m is 4, we get this as 16, this part, 20 minus m. Okay, so we end up getting the same answer. Suppose we take m as 16, then m is 4 out here. Either way, we'll get the same answer, 4 root 5 and 8 root 5. That was question 6. So I showed you the short way and then the two long ways. Question 7. We have got this star drawn like this. Yeah. So that's a star. And there are angles out here on the vertex. So if the lines forming the star above are all straight lines, then find the sum of the angles at A, B, C, D, and E, as shown in the picture above. So out here, we'll apply the exterior angle theory that this angle Z is equal to the interior angles X and Y. Interior remote angles, not adjacent ones, remote angles X and Y. So Z is equal to X and Y, right? That's a property. And I've already showed you in the review number 1 or 2, I think 1. Yeah, I've already shown you this part, how Z is equal to X plus Y. So I'm not going to repeat that. So out here, call these angles A, B, C, D, and E. So now, this is my exterior angle. Let's consider this is my exterior angle for this triangle out here, EB, and this one. So exterior angle. Therefore, this is E plus B. This angle is E plus B. And then similarly, this is the exterior angle for this triangle in yellow, A and D. So out there, this angle will be A plus D. And this one in the blue is a triangle with angles A plus D plus C plus E plus B. And we know the interior angles of any triangle is 180 degrees. And hence we get this answer as 180 degrees. Okay. Yeah. D is your answer. D. Question 8. If triangle PQRS is a square, and so are all the squares drawn within it by joining the midpoints of the sides of the outer square. So these are the midpoints, and by joining them, we are forming squares inside. Yeah. Given PQ is 6, so this is 6 centimeters. Find the ratio of the diagonal of the innermost square to the diagonal of the outermost square. So this is fairly easy question. So we know that if 6 is the side of the outer square, then the diagonal will be 6 root 2. So the outermost square, the diagonal is 6 root 2. What do they want? They want the ratio of the diagonal of the innermost square to the outermost square. So therefore, we'll have a division. So this is at the bottom and the innermost square. Now, if you see, we got the diagonal of the outermost square 6 root 2. Okay. Now, if you see the diagonal of the second square inside is also the side of the outer square. Okay, right, right. So therefore, the side of the inner square will be 6 by root 2. Okay, we are using the right isosceles triangle property. Yeah, x root 2x. So if root 2x is 6, x is 6 by root 2, like that. Right. Now, if you see the diagonal of the third square inside, yeah, there are four squares. First is the outermost square, second inner, third inner, and the fourth innermost, like that. So the diagonal of the innermost square is 6 root 2, right? This red one is 6 root 2. Yeah. So therefore the side of the third square is 6 root 2 upon root 2, right? I'm sorry, 6 by root 2 upon root 2. So 6 by 2. My bad. Okay. So this one is 6 upon root 2. My bad. 6 upon root 2. So therefore the side is 6 upon root 2 and then upon root 2. So that is 3, 6 by 2. Okay. And this side, 3, is also the diagonal of the innermost square. Okay. Therefore my answer is 1 by 2 root 2, the ratio. Yeah. E is the answer. Okay. Right. Question 9. Now, if there were like, before going on to 9, just to give you an idea that if there were like, picture was not drawn and they said that there are 20 concentric squares, then you need to understand that the diagonals went in this way. Yeah. So if you see, there was a ratio, it was a geometric progression. Yeah. Where the ratio is 1 upon root 2. Yeah. Every term got multiplied by 1 by root 2. So you could have used geometric progression out here, the formula for geometric progression. I think sequences is not covered, so I'll cover that in my next series of lectures. And also data interpretation and a little bit of logic where, uncle and father's daughter and daughter is sister and all that. So some 10 more videos and we should be done with the part A. Okay, so geometric progression series, I'll teach you separately the sequences. So for the time being, just remember that if there were 20 concentric squares, then you would require your geometric progression uh, formula to solve this question. Anyway, right, moving on to question 9, and after 9, we wind up. Okay. Okay. Question 9 is that in the given circle above, arc AB is 120 degrees, Q is the center of the circle, and X is the angle on the circumference. That is this angle on the circumference. Subtended by the arc AB, then find the measurement of angle M. So if you remember the cyclic quadrilateral concept, okay. So first of all, there's cyclic quadrilateral concept also and the circle concept also. That if the angle subtended by the arc AB, yeah, at the center, yeah, if arc AB is 120 degrees, that means it is subtending angle at the center, which is 120 degrees, like that. Therefore, the angle subtended on the circumference is half of this 120 degrees. So once we get x as 60 degrees, remember m is easy to be found out because this A, B, and these two vertices, I would say, these are cyclic quadrilaterals, and in a cyclic quadrilateral, the opposite angles are adding up to 180 degrees. Opposite angles are supplementary. So if this is 60 degrees, m is 120 degrees. Then find the measurement of angle m. Angle m is 120 degrees. Understood? There's another way to also solve this question using this concept only, that if the arc AB subtends 120 degrees, that's the minor arc, then this is called the major arc. This is called the major arc. This blue line, this blue part of the circle of the circumference is called the major arc. And that subtends angle 240 at the center. If subtends 240 at the center, then from that very point on the circumference, it will subtend an angle which is half of 240, which is 120 degrees. So that's another way to solve it. Okay, so that's it. We'll stop here. Review 5, yeah, and then we'll complete 10, 11, 12, 13, 14, 15. So there are 6 more questions to be solved. Yeah, 7 more questions actually. No, 6 more. 10, 11, 12, 13, 14, 15. 6 more questions that we'll solve it in Geometry Review 6. Thank you.